What is an index? Let's go back to finding that book at the university library in a 5-story facility. Wouldn't it be nice if there was a record somewhere that said, Greg's thesis, third floor, second stack, fifth shelf, third from the end? Maybe you're old enough to remember the library's card catalog. Maybe you're not. In the olden days, the card catalog was just a small box of cards with the coordinates for every book. It's like taking every book in the building and boiling it down to 2 pieces of information: the attribute you're searching for, title, and its location. Card catalogs typically had more than one set of cards. The first set would be based on title, the second set was based on author. And one other key aspect of a card catalog is that it's sorted on the attribute you're looking up, title or author. Because the card catalog is sorted, you can find an entry quickly, and then it tells you where the book is. That's what an index is. For a given table of information, you can build any number of indexes based on the attributes you need to find things. Imagine our library with 10 million books. People often search on title, so a key index to set up would be based on title. Create index on book title. This will create a card catalog in the database that has the title of every book in it, and that index is sorted by title. And what's in the index when you find the entry? The actual location of the row of the book table with that title. With that information, the database engine can jump straight to it. Now, this works whether we're talking about some monolithic database where the blocks of that row are on the same server, or in a distributed database and the row you seek is on the other side of the globe. When you type select star from book where title equals Spring Data, the database engine is able to quickly find the entry for Spring Data in the index in logarithmic time. Then the index entry will tell it exactly where that row of data is. As your database grows inside, indexes become paramount in finding data. In fact, indexes are one of the most performative things you can apply to your database. Imagine a database with 10 million books and no indexes. What does it mean to do that query you just saw? It would require a full table scan. That literally means scanning every single row. That ain't cheap. But with a single statement, you can create an index based on title and run the query again. The database engine will then scan your newly minted index to find the entry. Remember, the index is sorted. The database engine jumps to the middle. From there, it figures out if it overshot. If so, then it throws away the lower half. Otherwise, it throws away the upper half. Rinse and repeat. With 10 million rows, the database engine can find the entry in 24 hops or less. Instead of checking 10 million rows, it instead just needs to check 24. This is a binary search, and it's only possible in a sorted collection. Indexes provide sorted subsets of your data, allowing search efficiency to scale by an exponential amount. This is the reason many blurt out, "Create an index," when anyone asks, how can we speed this query up? It's also the reason you can actually hinder things when creating the wrong indexes. Remember that card catalog? A separate boiled down copy of the database that is sorted for your benefit? Think of an index as a secondary database that the engine maintains on your behalf. What happens to an index when you add another book to the inventory? Not only is it added to the book table, it must also be added to the index, and it must be put in order just like the other entries. If we're talking about a single new book, that's not a problem. But what if we're talking about 100,000 new books? In addition to inserting the same rows into the book table as before, you must also add 100,000 new entries to that index, and those new entries must be sorted. Now, it's certainly possible. Just sort the incoming data set by title and then do an insertion sort, but it's certainly not free. There is a cost. And once the job is complete, the query we used earlier, but instead redirected to look for one of the new titles, would look like this. Select star from book where title equals Spring Data 2024 edition. And it will soar, probably in sub-second time. Now, is this the only hindrance that comes with indexes? Well, fortunately, no. Indexes sizzle when someone asks for one book. The index quickly tells you where it lives, and that's awesome. But what happens when you're looking for a bigger result set? Imagine something like, find every folio in the library and flag it for audit. Folios are uniquely formatted books. This includes oversized books, microfiche, and other odd types that don't fit on regular bookshelves. As a consequence, a library's inventory of folios must be audited periodically to ensure they're available for checkout, or they can be scheduled for repair or replacement. If you were the director of the library and you wanted to schedule such an audit, you need to know all the books that are in this format. And so you'd write something like this: select star from book where format equals folio. In a library with 10 million books that has an index based on format, instead of giving you a single entry in that index that you visit once, you may instead get 100,000 entries. That may only be 1% of your inventory, but imagine using an index the way we just did earlier. Basically, you're visiting the card catalog, finding a stack of entries, and then having to visit the actual books amidst the library 100,000 times. What if the query you wrote hit 10% of all entries? 40%? 80%? At a certain point, it's actually faster and more efficient to sidestep the index and simply visit every book in the library. Going to the index, getting a subset of books, and then visiting every entry may actually be slower than a full table scan. I'll mention that there are actually different types of indexes. One of them is known as a covering index. This is an index that not only has the search criteria sorted, it also has the columns already stored in the index. This means that your entire query is served by the index itself, not requiring that you go to the table. There are trade-offs when you do this. For example, would you want to put all the columns into a covering index? That requires a lot of disk space and an increased amount of I/O to maintain it. This is just some of the tidbits concerning one type of index. There are actually many types of indexes and out of the scope of this video series. The point is that the old adage of just creating an index can sometimes be wrong. Now, I've said it before, rules of thumb work until they don't. We can build all kinds of indexes to help with queries, but on occasion, we need to signal that we've done enough research, and for this query, we do not want to use the index. And this is exactly what query hints are for.